We have derived the relation for the polytropic process PV raised to power x equal to constant, where x is the polytropic index equal to C minus Cp by C minus Cv, or we can write it as Cv plus R by 1 minus x, or it is R by gamma minus 1 plus R by 1 minus x. Because different processes like isobaric process, isothermal process, adiabatic process, isochoric processes are also the polytropic process. Therefore, we can find the properties of these processes using the equation we derived. First, we take suppose isobaric process. In isobaric process, the molar heat capacity is equal to the molar heat capacity at constant pressure. Therefore, its polytropic index is C minus Cp by C minus Cv, that is equal to Cp minus Cp by Cp minus Cv, and it is equal to 0. Therefore, Pv raised to power 0 equal to constant, or we can say that P equal to constant. So, in isobaric process, pressure remains constant and the polytropic index is 0. Second process is isothermal process. In isothermal process, molar heat capacity of the process is infinite because there is no change in temperature. We know C equal to dq by n dt, and this change in temperature is 0 because isothermal process has constant temperature. Therefore, this C is tending to infinity. If this C tends to infinity, then polytropic index x will be equal to C minus Cp by C minus Cv, and for this limiting case of C tends to infinity, we divide numerator and denominator by C, so we will have 1 minus Cp by C by 1 minus Cv by C, and substituting value of C, this term will become 0, this will term tends to 0, so we will have the value of x1. Therefore, the equation for the isothermal process will be Pv raised to power x, and x is 1, that is equal to constant. So we can write Pv equal to constant for the isothermal process. Third is adiabatic process. Adiabatic process is the process in which there is no exchange of heat. If there is no exchange of heat, in that case, its molar heat capacity will be 0 because C equal to dq by n dt, and there is no exchange of heat, so C will be 0. If C will be 0, then polytropic index x equal to C minus Cp by C minus Cv, that is equal to 0 minus Cp by 0 minus Cv, that is equal to Cp by Cv, and Cp by Cv is the ratio of the molar specific heat at constant pressure and constant volume, and it is mentioned as gamma. Therefore, the equation for the adiabatic process will be P raised to power x, and x is gamma, that is equal to constant. And fourth process is Isochoric process. In Isochoric process, C, that is the molar heat capacity of the process, is equal to the Cv, that is constant volume, specific heat or molar heat capacity at constant volume. For this case, the polytropic index will be C minus Cp by C minus Cv, and C is Cv, so we will write Cv minus Cp by Cv minus Cv, so it tends to infinite. Therefore, we can write the equation for isochoric process is Pv raised to the power x, and x is infinite, that is equal to constant. If we draw the PV diagram, that is the pressure volume diagram of the different processes, we will get the graph like on x-axis we take the V volume, and on y-axis we take the pressure of the gas. And first process, suppose this is the process, here pressure is constant, so this is the isobaric process. Isobaric process will have a line which is parallel to the volume axis. It means pressure is constant. It is isobaric process, and for isobaric process, X, that is the polytropic index, is 0. Similarly, another process is like here this process volume is constant. For this volume is constant, it is called Isochoric process, and for this process polytropic index X tends to infinite. Similarly, graph for the isothermal process is the rectangular hyperbola. This is isothermal process, and for isothermal process the polytropic index will be 1. And one more process is adiabatic process. It is more steeper than the isothermal, and its polytropic index will be X equal to gamma. That is the ratio of the specific polar specific heats at the constant pressure and volume. And this gamma is greater than 1, so it is more steeper than the isothermal process.